Welcome to a journey through time, where the Earth's surface is in constant motion, shaping the world as we know it. Our planet, a sphere of vibrant life, harbors a secret beneath its surface. It is in constant motion. The continents we inhabit, these seemingly steadfast land masses, are not fixed but adrift, sailing across the Earth's mantle like ships on a vast ocean. This is the essence of the Continental Drift theory, the idea that continents have moved over geological time. Imagine a time when the continents were once united, forming a supercontinent called Pangaea. This giant landmass eventually broke apart and the pieces drifted to their present locations. The movement of continents has shaped the face of our planet, influencing its history and landscape. The Continental Drift theory challenged the long-held belief in static continents. It opened up new avenues of thought, leading to a deeper understanding of earthquakes, volcanoes, and the formation of mountain ranges. The Continental Drift theory is a cornerstone of the modern geology, providing a framework for comprehending the forces that have shaped our planet over millions of years. The idea that continents might be moving is not entirely new. As early as the 16th century, Flemish cartographer Abraham Ortelius observed the uncanny fit of the coastlines of South America and Africa. He proposed that the Americas were torn away from Europe and Africa, perhaps by earthquakes and floods. In the centuries that followed, other naturalists and geologists noted similar geological and fossil similarities across continents separated by vast oceans. These observations hinted at a deeper connection, suggesting that the continents were once joined in a supercontinent known as Pangaea.
One scientist who dared to explore this possibility was Alfred Wegener, a German meteorologist and geophysicist. I was fascinated by the apparent jigsaw puzzle fit of the continents and intrigued by the growing body of evidence suggesting that continents have drifted apart over geological time.
In 1912, Alfred Wegener presented his groundbreaking hypothesis of continental drift to the Geological Association in Frankfurt, Germany. He proposed that the continents were once united in a supercontinent, Pangaea, which later broke apart, with the continents slowly drifting to their present positions.
My theory, published in 1915 as The Origin of Continents and Oceans, was met with skepticism and even hostility from the scientific community. My ideas challenged the prevailing view of a static Earth and lacked a mechanism to explain the movement of continents.
Despite the initial resistance, Wegener's theory was not without its supporters. A few visionary geologists recognized the compelling nature of the evidence he presented. However, it would take several decades and the emergence of new scientific tools and data to confirm the validity of Wegener's revolutionary idea.
What evidence did I present to support my seemingly outlandish theory? I pointed to the remarkable jigsaw puzzle fit of the continents, particularly the coastlines of South America and Africa. But my evidence went far beyond the visual.
Wegener meticulously compiled geological data showing that identical rock formations and mountain ranges extended across continents now separated by vast oceans.
I also presented compelling fossil evidence, demonstrating that identical plant and animal fossils were found on continents now widely separated. These findings strongly suggested that these landmasses were once connected.
Further support for Wegener's theory came from paleoclimatic evidence. He pointed to the presence of glacial deposits in tropical regions, suggesting that these areas were once located closer to the poles. Conversely, evidence of tropical swamps in now polar regions indicated that these areas were once located closer to the equator. These climatic discrepancies could be explained if the continents had indeed shifted their positions over time. While Wegener's theory of continental drift was initially met with resistance, it laid the groundwork for a revolution in our understanding of Earth's dynamism. The theory further developed and refined in the decades following Wegener's death, ultimately gave rise to the theory of plate tectonics. Plate tectonics, the modern version of Wegener's vision, provides the missing mechanism for how continents move. It explains that the Earth's outer layer, the lithosphere, is broken into several large plates that float and move over the semi-fluid asthenosphere below. These plates, constantly interacting with each other, are responsible for earthquakes, volcanoes, mountain building, and of course, continental drift. The legacy of Wegener's continental drift theory extends far beyond the realm of geology. It has revolutionized our understanding of the interconnectedness of Earth systems, influencing fields such as paleontology, climatology, and evolutionary biology. It underscores the dynamic nature of our planet, reminding us that the Earth beneath our feet is in a constant state of change, a slow but relentless dance that has shaped the world we know.